Okay, we're going to work on problem F7 here. F7 takes a couple of other problems and takes them to different planets here. For example, part A asks us about what if we took the pendulum in problem F3, what if we took that to Mars? And the acceleration due to gravity on Mars is 3.7 meters per second. All right, well, let's remember the expression for the period of a pendulum. That doesn't have anything to do with it. Let's remember the expression for the period of a pendulum is 2 pi square root of L over G, the length of the pendulum, and G is the acceleration due to gravity right there. So that's where the Mars issue is going to come in here. Okay, so F7 is asking about the period of the pendulum, so we're trying to solve for this. We know 2, we know pi. The L is given to us in problem F3, that's 7.5 meters. And the G is going to be 3.7 meters per second. So here we go. 2 pi square root of 7.5 meters over 3.7 meters per second. And then once we do that in our calculator, we come up with, let's see, I'll do 7.5 divided by 3.7, and then I'll square root that, or I'll get a syntax error and I'll do it right this time. I'll square root my answer and I'll come up with, there we go, 1.4. And then I multiply it by 2 and I multiply it by pi. And I come up with 8.9, and that's going to be 8.9 seconds. Now, this is the big idea here, is that this period, 8.9 seconds, is much longer than it would be on the Earth because the gravity on Mars is less. So there's less of a restoring force pulling that pendulum back to its starting point. And so the period is going to be longer. It's going to take longer for that period, for that pendulum to make a swing on Mars where there's lower gravity than it would be on Earth. Now, part B of this problem, what would be the period of the system from problem F4? And you read F4 is a mass hung from a spring and oscillates with a period of 2.4 seconds. What is the spring constant? Well, okay, so for part B, we remember that the spring constant for a mass on a spring is 2 pi square root of m over k. So here's the period, here's the mass, and here's the spring constant. Well, do any of these change when you go to the moon or Mars or Jupiter or a different planet? None of them. All three of them stay the same. The period, the mass, the spring constant, they all stay the same. So the period of the mass on a spring is going to be the same no matter where you are. And we're going to find that interesting. In problem 48, the very last one, this is a way that astronauts can use to find their mass. Even though they're not standing on a scale in the space shuttle, they can use a spring to figure out their mass because this applies everywhere. So the answer to part B is exactly the same as the answer for F4, which is 2.4 seconds. There's no difference there at all.